Ruby meta programming. So here we are going to learn the concept of meta programming, generic concept of it, and we are going to see Ruby language characteristics that makes it a great meta programming language. And then we are going to see respond to method of object class and send method of object class, and we'll talk about dynamic typing, and we'll also talk about special dynamic typing called the duck typing, and I will talk about missing method and define method. So what is meta programming? Meta programming is writing of computer programs that write or manipulate other programs or even themselves. So meta programming is a programming language that could be actually manipulating other programming languages. Okay. So why meta programming? So it provides higher level abstraction of logic, which result in easier writing of code and easier to read code. Okay, so meta programming features of Ruby language is what makes Rails a killer application. So many features of Rails are based on taking advantage of meta programming features of Ruby. For example, dynamic finders in Rails, you can actually have find by name or find by name and hobby. These are the methods that are not actually pre-existence. Like a name is an attribute and hobby is an attribute. So you can actually construct this find by name and and hobby kind of method dynamically in Ruby language, and it's possible because of meta programming features of Ruby language. And another advantage of meta programming is it's easier to write domain specific language like a DSL. So in these days, domain specific language is very popular because it basically is a language for a particular space. Like you could actually have a domain specific language for finance domain or the security domain. Or you can think of SQL is another example of domain-specific language. So how you're going to actually build this kind of domain-specific language like a DSL? You need a language that is, that has a high meta-programming features like a Ruby. Okay, so you could actually write, the domain-specific language using Ruby as a starting language. Okay, moving forward. So what are the characteristics of Ruby language, and that makes it a great meta programming language? So a few characteristics. Classes are open. Class definitions are in fact executable code, and every method call has a receiver, and class themselves are objects. So this sounds probably pretty too abstract for you guys, right? So let's actually talk about each of these in a bit more detail. Classes are open. What does that mean? That means during runtime, methods and variables can be added to the class. So like in Java and C++, you have to have these methods predefined at the compile time, right? There is no way you can add new method to Java or in C++. In Ruby, it is possible. During runtime, you can add new methods. So this is an example. Even the built-in class like a string class, you can add new methods. So if you define class string and then you are defining new method like a def encrypt, so basically I am adding a new method called the encrypt to string class, and then I can call it. So here it will display cat, and then if I call encrypt method, which I just added to the string class, then I should be able to invoke it. Okay. Okay, so benefits. Application can be written in higher level abstraction, and it's going to be more readable code. So basically all I have to do is just another method to the string class. Okay. Now you might want to say, in Java, or any other language, does it have to be done at the compile time or things like that? But in Ruby, in fact, this class is a method. So this is being in fact executed during runtime. So you're actually adding this def during runtime. Okay, so I'm going to actually talk about that aspect later on one more time. And how it is used in Rails. Anyone can open up the Rails classes and add new features, mostly method in the form of methods, to them to suit their needs. So you can actually change, any class in Rails. Okay, so that is Rails very flexible. Well, some people call it malleable. Okay, so this is the point I was actually trying to make. Class definitions are in fact executable code. Okay, so this is the definition of the class, but class is in fact the method of class. So when you have this Ruby code, basically each of this line is being executed during runtime. So it's calling class method and then the name of the class. This is an argument. In fact, you can actually have class parentheses, because class is a method and logr as a name of the class is an argument. In Ruby, because you don't have to have a parenthesis, that's the reason you don't see the parenthesis, but you can have a parenthesis like here. Okay, now this is actually interesting because these class definitions are being executed, okay, during runtime. We can have in fact if and else. If debug environment is set, then we are going to set log method with this. Otherwise, log method doesn't have any code. So this is being executed during runtime. Okay, and as I said, class is an object as well. So here we define person class, and if I say what is the self, then you are going to see this is going to display person. And whenever you want to find out the type of that class, then you can say dot class and it will display class. Okay, and then this is the class method. So self.myClass method, it just displays this message. Okay, so that is exercise 0. So let's take a look at the let me unzip the zip file. So zip and let's take a look at the lab documentation and labs meta index. Okay, so exercise 0 is Ruby classes. So this is the same code that I actually mentioned in the presentation. So when you run the code, it will cat and dbu, and I want you to do for your own exercises, okay, and on your own time. Class is executable code. So this is something that is interesting. So here, let's actually open. I'm going to open folder, and I'm gonna just do here, and that's Ruby meta s equals e. Okay, so it's Ruby meta class definitions. Okay, so this is the code. Okay, so this is the class method is being invoked, and depending on whether debug is set or not, it will use different method. The log method is defined differently during runtime. Okay, all right. So in this case, what we're gonna do is we are going to run it. Okay, so for now the debug is not set, so it will just nothing will be logged out. So when you call the log, nothing will be logged out. But when we set the debug, okay, so let's actually see whether Control B and nothing is being displayed. Now let's see whether I am going to set the yeah, I'm not sure whether this is going to be picked up by okay, so let's see whether that will be picked up by this guy. Okay, so I think that environment is not picked up by, so I'm gonna actually probably do the command line. So I'm gonna go to the yeah, so here let's go to samples, and so I'm going to run the code using Ruby command. So here, so nothing will, oh yeah, so I actually set the debug, right? Okay, so I'm gonna actually now unset it. So I'm going to unset it. Now if I run the code, then nothing gets displayed. So the key point in this case is that even a method can be defined differently during runtime. Okay. Okay, so that is that, and you can actually take a look at the methods of class, and you can see the class is in fact one of the method of class. Okay, and you can call class method defined. So method defined is one of the methods that you can call for any class, and then you can see whether class is one of the methods defined in class, and it should actually return true as we verified here. Okay. Okay, class is an object, so here, yeah, this is the same code that we have seen. Okay, all right, so that is exercise 0. So let me actually continue. The respond to. So introspection. So Java has introspection as well. So it's basically the capability of being able to find information about an object during runtime. So you can find the class information, you can find all the methods, you can find the superclass, you can find all the ancestors, you can find all the private methods, public methods, and things like that. Okay. Respond to is basically to check whether a particular method is present for that object. Okay, so in this case, we have defined hello method, and it does have a single method called my hello method. Okay, so we created hello instance by calling new method of hello class. Okay, so this is the class method. So now I'd like to find out whether this hello instance, the type of this hello instance has in fact my hello method. So I can actually call respond to question mark and the name of hello method. You can actually have string value instead of the symbol, and it should return true. Now if you remember, when I actually talk about the origin of Ruby language, and or actually similarity with the small talk, and one of the bullet items says that a method is basically by sending a message. So that's the reason we respond to. So basically whether this object will respond to this method name. Okay, that is basically what the small talk language is all about. So basically respond to is indicating whether this method is present or not. Okay, that is respond to. So let's do exercise 1. So we are going to see the introspection method. Yeah, so here we are basically seeing the class of string object. It should actually string, and the superclass is a class. So class is superclass is object, and you can also actually see all the ancestors, and you can find all the methods. You can also see all the private instance method, public instance method, and things like that. So you can see all those things are in fact being displayed here. Okay, so this is introspection, and this is respond to. Okay, so let's actually do this is the introspection respond to. I'm gonna just do this, and Ruby meta intro respond to. Okay, so this is the one. Okay, so here we'd like to check whether my method is present or not, so that should return true. However, if I try to see whether XYZ method is present or not, that should actually return false, right? Okay, so let's actually run this code. So the first one returns true, and the next one returns false. So if I define XYZ method, I'm going to define XYZ and like this, and then it should return, this one should return true as well. So let me save and run it, then it should return true. So basically respond to is used to check whether that method is present or not. Okay. Instance of instance of, which I have not really talked about is in the presentation, is pretty straightforward concept. So we have a class A, and class B is a child class of A, and then we create an A object and B object from A class and B class. So A is instance of A, that should be true, right? However, B is an instance of A, that is not the case. B is an instance of B, not actually its parent. Okay, so this one should return false. But the kind of is dealing with all the ancestors as well. So this B is a kind of A, and that should return true. Okay, all right. Okay, moving forward. Send. So we have seen respond to, right? So it's like method is sending some message to somebody, right? So that is the paradigm of from a small talk. So when you're calling a send with the name of the method, you're basically calling a method. Okay, so let's see why this is in fact useful instead of actually just calling a method as we have seen so far. So this is a way that we are calling a method. So if there is a method called hello, we are calling that method hello and passing an argument. So this is the way that we have seen so far in terms of how to invoke a method, right? Okay. And now you can use a send method. So instead of calling hello method, I can say send and the name of the method and argument. Okay. And any string can be replaced by symbol. So I'm going to use a symbol as well. So these two are the same thing as this. These three guys are the same thing. Or I can assign the name of the method into a variable called, so I have a variable called the A method variable. And then I can pass that variable inside string interpolation. Okay. So all these guys, this one and this one and this one and this one, they are doing the same thing. It's actually invoking my method. So why you want to use this kind of notation as opposed to this? The reason is because if you're using this syntax, basically you are hard coding the name of the method. Suppose if you want to change, invocation of the method depending on some kind of business logic or some kind of condition, like a time of the day, or even depending on your mood, you can actually change the name of the method, with the different value, right? So here I'm just assigning my method, but this could be computed. The value of this A method could be computed during runtime based on business logic or based on some kind of condition, right? So it actually makes your code a lot more flexible. Okay, so you don't have to actually hard code the name of the method that you have to call. Instead, you are going to determine the name of the method during runtime. Okay, and then you're going to use the send method. Does that make sense? So it's a lot more flexible. Okay, so in this example, we have defined class, and it does have a hello method, and it takes this argument, a variable number of arguments, and all it does is basically hello and argument join with the space. Now, all these 6 guys are the same thing. So here, this is the way that we call, right? So we pass 2 arguments using parentheses. Here, we don't have to have a parenthesis. And now, instead of using hello method, I'm going to call send method, and here I'm passing hello, the string, and again, I don't have to have a parenthesis, so the parentheses are omitted here, and here I'm using symbol instead of string, and it does have a parenthesis, and here I don't have a parenthesis. Okay, so all these 6 guys are in fact doing the same thing. The result is going to be the same. Okay, but the key point is that this value, this could be a variable, and that variable could be set during runtime. Okay, so invocation of the method could be the set during runtime, and that is providing huge flexibility. Method class. So you could also have a method. Okay, so here I am going to call method of a class, and this is the name of the method. So basically this length method is actually pointing to an object that contains this length method. Okay, so then I can see, if I can see the type of this class is a method, right? So method is in fact another type. Okay, and then I can call it. Okay, yeah, this is probably not the thing that you see often, so don't worry about it if you don't understand this method class. Okay, so exercise 2 is send. So basically, we are so we are calling. So this is basically calling the length method of random text. So this is return 11. So this is 11 characters, right? And here, instead of calling each directly, I'm calling send method and then passing the name of the method and then code block. Okay, so this is basically the same thing as the each. Instead of each, I'm actually using send and just passing the name of the method. Okay. Yeah, this is the same thing that I actually explained in the slide. Okay. And so in this case, yeah, so this is an example where you are basically using a variable. So I have a variable, method variable, and this could be actually set during runtime through some business logic. In this case, I'm just using the hello symbol, but it could actually call a method, and the method could return hello or something else, and then I'm going to call that method through this variable. Okay, so I can use this variable like this, or I can use string interpolation like this. Okay, so this is probably more straightforward. Okay. All right, that is that. And as I said before, even operators those are all methods. So as we talked about, 2 plus 3 is basically the same thing as this. Because this is a method, we can actually use the send method, and then we are passing the name of the method. In this case is plus. And then you don't have to have this parenthesis. Okay, so it just kind of proves that everything is an object, and object has methods, even this plus operators. Does this make sense? So let's actually play around with this one again. Ruby meta object, the send plus. Okay, so this is the code, right? So basically when I run this code, it all should work fine. Okay, so in this case is the multiplication, and then we are using send. Okay, all right, method object. So that's something I talked about using the slide. And call methods through method array. So you could even have a methods array. So let's actually see this code. So we have hello class, we have initializers, and we have my hello method 1, my hello method 2, method 3. Okay, and we have hello instance. Now we have hello methods array. So basically, it's an array of these names of the method. I can actually change this guy using symbols rather than this string. Okay, and then basically I'm going to call x, and we have actually for each. And each is basically receiving the array object, so method array. Yeah, so we basically method array, and for each, so each of this method will be provided as the name of the method to invoke. Okay, so it will call these 3 methods in sequence. Okay, so let's say send the method array. Okay, so when I call this guy, it should all return the values. Okay, and I can just change this guy to as a symbols if I want to. So I'm gonna remove this guy, and that should work the same. Okay, so let's see. So that is the method array. Okay, so let's move on to dynamic typing. Dynamic typing and doc typing, we're going to actually talk about these two. So what is dynamic typing? So programming language is set to use dynamic typing when type checking is performed at runtime as opposed to compile time. So we already have seen examples of variable A is assigned with a different type of values, and the type gets determined during runtime depending on what value it is assigned to. Okay, so pretty much most of the modern languages support this dynamic typing, and other languages such as Java and those are the static type language. Okay, so I don't want to get involved in terms of which one is better. Each has its own strengths and weaknesses. Okay, so there are reasons why dynamic typing is useful in some languages, and there are reasons why static typing could be useful in some languages as well. Okay, what is doc typing? Doc typing is a style of dynamic typing in which an object current set of methods and properties determine the valid semantics rather than its inheritance from a particular class. So basically what doc typing is all about is behavior. As long as it's actually behavior is providing some kind of the class is providing some kind of behavior, then you can actually kind of consider a particular type. It's called the doc type, and if it walks like a duck and quacks like a duck, then I would call it a duck. So this is probably the famous computer science sentence, I would say. Okay, so we have a doc class that has a quack method, and we have a malloc has a quack method. Okay, and then what we are going to do is we have the birds array. So we have a dog object, malloc object, and then we have non dog object, like we create some object. So we have a quack dem, and we are passing these dogs. So we are actually receiving some dogs as an argument, and then we are gonna just execute. We are basically checking whether that object has a quack method or not, and if it does, we're gonna just quack it. Okay, so this is the definition of the method. Then we're going to actually call that method passing this birds array, and we are going to actually have these two, dog and malloc will quack it. Okay, so basically those two classes have quack behavior, and basically we're going to actually consider those two classes as doc type in a sense. Okay, nothing fancy. So exercise 3 exactly that. Okay, so we can see dog is quacking, malloc is quacking, but this guy is not quacking. Okay, moving forward. Missing method. Okay, so if a method that is not existent in a class is invoked, you are going to experience no method error exception. So let's say we have a dummy class which does not have any methods. So I created dummy object here. Then if I try to call a method that is not present, then you are going to experience no method error exception. That makes sense, right? Okay. So nothing special in this slide. However, now if you have defined a method missing method in your class, okay, what happens is that when you are calling a method that does not exist, this method is going to be invoked with the name of the method you just call. So that is going to be a method that does not exist and arguments. If you call with an arguments, the arguments will be passed as well. So basically this method missing, you can do anything you want. Okay, so in this case we're gonna just display the message. This method is called with this set of arguments. Okay, but by intercepting any missing method, you can actually provide the behavior that is desired. So this is pretty powerful feature. So that's the reason, like in Grails, it does support what is called a dynamic finder. So when you call find by and xxxs is name of your attribute of your domain class, like a name, hobby, birthday, or something like that, and you don't actually have those methods predefined, right? So when you call find by hobby method, that will be captured by method missing method of your finder class, and then it will actually perform some kind of find operation for you. It will leverage whatever find method that is present, and it will actually do something that is actually supporting this this method. Okay, so here we can say find something, and then we can say find by last name, or find by title, or by last name, or something like that, or end, or something, right? So those kind of methods that are not in fact present in your class. However, those behaviors of those could be actually provided through method missing. That is what the method missing is all about. So that's exercise 4. So exercise 4 is basically so if you call this guy, you are going to experience no method error exception. Okay, so now if you add method missing, so this is the case, method missing. So let's actually try method missing called. Okay, so if I run this guy, you can see this is being displayed, and with arguments arg. So the first call, it doesn't pass any arguments, so argument is nothing. And yeah, let's actually just, this is just too much message, so I'm gonna just, and yeah, so I'm gonna just run this guy. Okay, so this message gets displayed because none of this method does not exist, right? So method missing will intercept it, and it will basically display. Oh, I want to display this the actual method name as well. So I'm gonna just use like this, and let's run it. So a method does not exist called with arguments nothing. In this case we are passing 3, so it does have 3. In this case, passing 3 arguments, it will actually display these 3 arguments. Okay, so it actually shows that method missing is invoked when a method is invoked that is not present. Okay, so that's the idea. This is actually simulation of the find. So in this case, method missing finder. Okay, so we have a find method present, so this one should work fine. Okay, however, we are going to actually try find by last name and find by title. Okay, so if I run this code, okay, so you can see find by last name and Shin is called. So basically you can simulate the behavior of this. Okay, we are basically just displaying the remainder of the finder, these things and arguments. Okay, I actually explained the logic here in detail, so take a look at that if you are curious how this is actually working with the regular expression and all that stuff. Okay. Yeah, one good example is like this: Roman integer.rb file. So suppose I want to create a method that actually convert these Roman characters to the integer. You certainly cannot create individual method that actually does all these things, right? Because there are infinite number of these Roman characters that make up the numeric value, right? So this is a great example where you want to in fact take advantage of method missing. Okay, so let's actually let me try Roman. Okay, so let's actually run this code. So basically what I want to do is, for this I want to convert into integer value. So this is going to return 4. So this one is going to return 23. This is going to return 2000. Okay, so you certainly cannot define all the methods that represent of this guy, right? So because again there are infinite number of things, right? So this is a great example where you can actually define a method missing, and then you are going to use some kind of logic. You are going to actually some kind of logic to convert into integer. Okay, so let me just use this guy. So this one should return 5. Yeah, so it returned 5. Okay. Okay, so that is another example of method missing. So let me actually talk about the define method. Define method defines an instance method in the receiver. So basically, if you want to define a method during runtime, this is the way you could do it. So basically, I want to define a new method with this code block. Yeah, you can use either way. So in this case, you are using the name of the method, and this is a method object. Or you can actually pass a block like this, and this block will be captured as a method of the symbol. Okay. So this method parameter in this case could be either prog object or method object. Okay. Okay. So and then in this case, if you are passing block, then it will be used as a method body. So we have defined love method, and we have define method, and we have my hello. So in this case, basically we created my hello method with this code block. Okay, and then we can call my method just like a regular method. Okay, right? So in fact, you can actually assign this logic to whatever method name of your choice. So here I kind of hard coded, right? My hello, but this could be set as a variable, and that variable could be actually depends on the business logic. So the idea in this case of define method is that you can actually create any method of your choice during runtime with whatever name of your choice. Okay, so it's again very flexible. Okay, so that is a define method. So here we define, so this is the same example. Okay, again, this so this one could be actually variable. Okay, so let's actually try. I think I have another example like that. So I have the variable called the my method gets. And in this, so this is a case that, we want to ask a user what is the name of the method you want to actually create. Okay, so gets is actually input and output. It's going to ask a user to enter something. Okay, so once user enters something, I'm going to actually use that name to create a method that contains these values. Okay, so I'm going to run it at the command line because I need to enter some values. Okay, so this is Ruby meta define 2. Okay, so let's go to this is meta. Okay, so and we are going to run it. Ruby meta RB. Ruby. So it's going to ask me what is the name of the method that you want to use. So I'm going to use my favorite name of a method XYZ. Okay, and then the XYZ is used. XYZ is used. So basically creating XYZ method from this variable, and then it actually invokes it. So you can actually see it should actually display method. Why did it not actually display XYZ? That's interesting. I see. So this is a method. Okay, so I actually use so I don't know why it has another it looks like it's actually have a new line right here. Okay, so this is the name of the method gets displayed from this puts. Okay, so that is the define method, and you can actually define methods through a method array. Okay, all right, so that is the end of the presentation. Okay, so it's now 5 o'clock, so I am going to